This is Eric Walden. I'm making a video to submit with the application for the internship for SpaceX. What I got here in this black box is a MegaSquirt 2. It's a DIY EFI system, and it's meant to manage the fuel injection and ignition output of an internal combustion engine. So it's set up specifically for a Turbo Miata. That's going to be used with the Baylor Driving Club's race car. So I'm just going to run it through. I got hooked up to my computer with a serial to USB converter. So yeah, so you can, and that's my tuning software right there. And you can monitor all the parameters. And then this right here is what's called a gym stim. I built that off of a kit as well, and basically it just simulates sensor inputs like a motor would. So actually I'll just turn it on and show you here. So we'll just flip that switch, and you can see it powers up the MegaSquirt. So pretty much what it does is you have all your if my camera will focus here, has all the motor inputs on the sensor. I'll point them out. Here's mass air temperature, coolant temperature, throttle position sensor, your O2 input for a O2 sensor wideband, spare pot, and then RPM. There's fine and coarse. So those are all just variable resistors, and you can turn them, and it will change its reading. If we can find, there you go, there's your manifold temperature, and it kind of spikes because I haven't set up the calibration curves yet for the thermistors. But yeah, so that right there, you can see the injectors firing. It also can let you view the outputs of the motor, or of the MegaSquirt. So those are actually the outputs being outputted by the MegaSquirt, and it'll light up when they're outputted. So I can slow it down a little more here, I hope. There we go. So you can see these two are my ignition outputs, and the two right there are my injector outputs. So it's running bank injection with wasted spark. So it only needs two outputs per, just two outputs per channel there. And then that's my fuel pump light, so that's would be going to my fuel pump relay. And this is my fast idle output, which I haven't tuned yet. Over here, you can't really see them because they're lighting up so quickly. But this is one of my ignition outputs, and this is another one ignition output. So it's actually, the outputs that you're seeing here are getting triggered by these outputs. And then this is my warm-up enrichment. That's just an indicator light. So if I turn up my coolant temperature sensor, you can see it go up right here. If we're lucky, there we go. So you see warm-up enrichment just went on. And then that light turns off. So you can tell when you're out of warm-up enrichment and you're good to go when it comes on. And you're up to operating temp at 180 Fahrenheit right there. So yeah, pretty simple. I'm going to go and actually open up the board so we can take a look at what's inside and all the sensor inputs and all that nitty-gritty stuff. So I'll come back when I take the board apart and show you some more. Okay, so we're back here with the board. I took the top of it off so we can see the insides of it. I built this board completely from a kit, so everything that you've seen here has been soldered on by me and modified to actually work with the Miata that we're building it for. So one thing that you can see are all these wires going into this board here that I had to build. What this does pretty much is it's the secondary tack input for the motor. There's two tack inputs, so one works fine. The other one needs to be modded so it can actually be read by the processor, because the processor is looking for a Hall sensor input. So that's all this does, is converts the optical sensor input that's coming off of the Miata into a Hall sensor output and goes into the MegaSquirt. Another thing that I did was I inverted the ignition outputs because the dwell time for the coils were way too long, actually completely opposite of what I needed. That's just the way that the MegaSquirt outputs its outputs. So what I have here, I'd said before in the other video that I had the ignitions triggered by these two LEDs here, and you can see that they have wires coming off of them, and I hope you can see that going into these transistors on the proto area there. And what this essentially does is when a input comes into the base of the transistor on each channel, transistor opens up and grounds the signal that's going to the spark. So whenever this light is on, that means that that ignition output is off. So that's why when I showed in the part before this how this light seemed, these two lights were ignition triggers, but they seem to be always on. That's because the dwell time, they're actually on for most of the time and off for a little bit, but they're actually going the exact same frequency as the lights they're triggering, obviously, which are here on the stimulator. The ones on the stimulator were being triggered with the inverter trigger, so they were only on for a short amount of time. That's why you could see them blink so clearly. So yeah, but basically every input and output has to be modded a little bit for the Miata or any car that you want to put this on. That's just the way it works. A big part that you need to do is wiring the routing the signals out and in onto this DB37 printer cable. That's what actually hooks up to the motor. As I said before, the stimulator connects to this and acts as the sensor inputs for the motor. That's what this is in real life, is a harness plug, and that plugs into your printer cable, and actually we splice that in to the stock engine harness so you can get your sensor inputs and outputs right there, and that just plugs in. This is the tuning cable that hooks up to the computer, so when you're actually in the car you can modify the parameters and monitor as well everything that's going on in the engine, which is very nice. So okay, so I just wanted to come back one last time and take a look at the ignition outputs. I have the main board connected to the stimulator and no computer output. We don't need that right now, but you can see we're running about 150 RPM, and our spark lights, spark LEDs, are these two right here going back and forth, and you can see how they're flashing so clearly. That is because they're the completely inverted signal of these two outside lights here, which don't seem to be flashing at all. That's because their signal has been inverted. So these are actually flashing, it's just the time that they're off is such a short time that you can't really even see it. What happens when the signal gets inverted is it goes out to these LEDs, which are only on for a little amount of time and off for most of the time, so it really seems like they're blinking a lot. These are actually blinking at the same frequency, and so that's how we actually get our spark to run. This way, when the MegaSquirt is actually connected to our Miata, when the computer is on but the motor isn't turning, so if you just haven't started the motor yet, your coil packs don't blow up, because that actually happens pretty often where the motor isn't turning, so the coils are charging but they're not firing, and they just overheat and they get ruined. So that is a nice little fail-safe from that happening. All we have to do is just tell the processor that we're actually triggering on the negative side, so we don't completely mess up our spark output. But that is a good help, and I just want to clarify that. So thanks for taking a look at my project, and thank you for taking a look at my application.